We will be discussing the concept of faunal succession and why it is beneficial for dating the relative age of a rock based on its fossil content. The principle of faunal succession was created by William Smith in 1815. Smith discovered that the different rock formations in England contained unique collections of fossils and that each formation possessed of properties peculiar to itself and has the same organized fossils throughout its course. Smith published these findings in the Geologic Map of England and Wales with part of Scotland as well as strata identified by organized fossils. Smith also established two different kinds of order in nature. These were the succession of ancient forms of life and spatial arrangement of rock units. Smith's ideas and work were initially ripped off by elites who plagiarized his work. Smith was only formally recognized in 1831 by the Geological Society. Afterwards he was awarded with the first Wollaston Medal. Faunal succession is helpful for relative aging. The graph on the right shows the relative age of a bunch of previously identified fossils. The red arrows show the extent of the age. So let's say we are mining a rock and in that rock we find a handful of fossils, some that we already know the age of and one that we don't. For example, one of the fossils we find is this shell shown on the right and we know the relative age of this as it is already on the graph. Next we are given a skull shown in the figure on the right that we also already know the date of. And after that we dig up another shell also shown on the right and we happen to know the date of this too. Finally, we dig up a fossil that we've never seen before, but since it was in the same rock as the other three fossils we can assume that the age of this fossil had to be alive at the same age as the other fossils. This allows us to obtain the relative age of the fossil shown by the blue shaded area on the graph. Knowing the relative age of these fossils can also help us determine the age of other rocks. For instance, let's say we find a fossil in Australia, and we can date it back to 300 million years ago. We can now assume that the rock the fossil is in is also roughly 300 million years old. Now let's say we find the same fossil on another continent, let's say Africa. Because we know this fossil is 300 million years old, we can assume that the rock in Africa has the same age as the fossils, which would be 300 million years old. Using the principle of faunal succession, the major areas in today's geological timescale were created. These time periods are the Paleozoic, ancient life, Mesozoic, middle life, and Cenozoic, new life. The division within the geological time scale are all based on periods when species of plants and animals went extinct or originated. These estimated periods of when species went extinct or originated were derived from dating rock layers relative to each other based on their fossils.